All right, so today, so back in December, I recently attended a Dev Intersection conference, and it was all about Azure, AI, it was about SQL, development, just Microsoft stuff. It was really good. Some Angular was there, and one of the concepts that I really got out of that, really enjoyed, was machine learning, and particularly automated. So to appreciate automated machine learning, let's talk about machine learning just in general so that everybody's on the same page. One thing I came to realize is, why is machine learning suddenly, hopefully everyone here has noticed that it's kind of risen up in popularity. It's more prevalent. It's like the industry changed. Well, it's been around for years, but why? One, it can solve problems a lot better than us. It's matured. There is a lot of scientific data around different methodologies, different algorithms. I would say at least that I know of, about 40 or more that I've seen. The other thing too is nowadays we are collecting so much data. Your phones, where you are. I'm sure all of you have appreciated the fact that Google tells you how long it takes to go somewhere. It's all learning. And more particularly, the conference I went to was all about the cloud. You can now massively run up multiple resources, compute something, and then spin them down. And your cost is pennies as opposed to hundreds of thousands of dollars of equipment. So there's some good blog articles there to talk about it. So one of the things that I wanted to also to understand machine learning, is the food here? No. Dang it. Okay. Yeah. This is good. Okay.
You all know that, right?
So one of the things that I discovered in my early understanding was a website called Kaggle. And I don't know if any of you have ever been here, but they are a site that's hosting lots of data, lots of opportunities, and competitions. I get emails probably on a weekly basis saying, here, you want $20,000 to solve this problem and be the top guy who's got the best algorithm. And I'm like, that's a nice thing I could try. Here in the local valley, I've also been to big data competitions, things like that, where people are winning prizes and monies. Honestly, the businesses are just winning because they're paying us pennies to go figure something out. But the industry is evolving. So here's an example of some of the competitions out there. If you do go and you're very new to machine learning, I highly recommend the first one there, the Titanic. It's a really simple example of, we know who died, we know who didn't. There's a couple in the data, there's a couple unknowns. We know how many people were on the roster. Can you predict who would die and who would not? You already know the outcome, but if you think about how machine learning works, there's a couple approaches. One of them is a fairly simple one, and that's, I'm going to get into that. Supervised learning. So supervised learning. So let's say we look at the Titanic example. Okay, 15? I think it was 2,200 something passengers. 1,500 survived. And if you take that 2,200 and you take about 70% of those users, just randomly take 70% of them, and you say, okay, I'm going to write an algorithm that predicts whether a person died or failed on that 70%. It's called the training set. Okay, so given that training set, I can run algorithms, I can test it, I can validate it, just like in math, you always check the answer, right? You can backwards fit it. Then take that algorithm and then match it to the remaining 2,200. Were you good or not? In some cases, you don't know all of them. You only know a small set in your data. That's an example of a supervised learning, okay? So as you can see, there is clearly a lot of decisions in machine learning. You have supervised, unsupervised. is, for example, where you don't know the outcome. Trying to think of another situation we'll get into here. Sentiment analysis. Any of you ever heard of sentiment analysis? Yeah, it's Twitter feeds, you know, somebody's, whether they're a bad review or a good review, for example, you don't know the outcomes of every answer. But there is a really simple initially set of decisions you need to make. And then from there, it just gets worse. So you have classifications, regression, and clustering. Those are generally what people in the industry have decided is a good way to look at a machine learning algorithm. So let's consider one of these. You know, I have a math degree, but I am not doing a lot of math. I'm doing computers. And some of these linear regression, discriminant analysis, the Gaussian mixture, this sounds like, you know, to a computer science guy, this sounds foreign. So like, how do I figure out which one to use? Well, a lot of machine data scientists, they know what they do, but they don't know whether they're going to be the best algorithm either. So what do? They spend a lot of time going through those and trying to figure out, okay, let's try this one. Let's run through it. Let's try this one. Let's run through it. So I'm going to talk kind of about one of the things, and I wasn't certain whether I should put this in a different order, but let's talk about one of those machine learning algorithms. I like to show kind of something that Visual Studio came across. They've just introduced ML.NET. Hopefully some of you have heard about it. So this is Visual Studio 2019. Okay, nothing flashy. It's the preview version. It's not quite released yet. I think they're in version 2 of the preview. Yep. And so online, you can find these samples pretty easily. I think I included them. One of them is the sentiment analysis. Okay. So if I walk through, you can see it's not a lot of code here. And let's kind of walk through this. And I'm going to make it a little bigger. You guys see that all right? Actually, isn't there a view presentation mode? Yeah, we'll just let it be. Okay, so first things first, you have a training data and you have test data. The training is, of course, building the model, and your test is, so in the example of the Titanic, your training would be 70% and your test would be the 2200. In this case, so we'd build and train the save model, which is down here. Okay, so we get our training data and our test data. Commonly process it, so transform. You can see that your data scientist or someone like myself is trying to gather how all this works. These right here are console helpers. You're going to train, and they're going to use a binary classification. Okay, so we're going to train the model and evaluate it, and then I'm going to print out the metrics. I'm going to save the trained model out so that I can look at it. And here's what's cool. So this is what you train. This is the data that your algorithms are going to run against. Okay. So let's go test it. Okay. So if we go back to the top here, we build it, then we go test it. And that's all this sample is. So for the benefit of our discussion, let's run one of these. And hopefully, I don't know how to make this bigger, or sorry, easier for you all to see. Hopefully you can see it. Okay, so you can see the output here, accuracy, 72%. It's looking at it, and then here's our test. So our test statement was, this is a very rude movie. Its prediction, is it toxic or not? Well, in this case, yeah. Wouldn't you say it's toxic, right? Pretty simple. But if you think about the consequence of this, you've trained a model, you've built an algorithm, you can now take that trained model and put it in your code somewhere else. And you didn't have to use Python or R or any of the other languages that a lot of the Microsoft developers just aren't familiar with. You now have machine learning.NET, to help you do the same concepts that those other languages are doing and train a model and then use it in your code. And you didn't have to get out of your skill set. So this is pretty cool for the Microsoft guys. This excites me a lot. So I could put this in my code and use it whenever I want. But the hard part, again, when we talked about this, I'm going to show you just a quick sideline too. Something else that Microsoft did. This is just a little sideline. Something else that Microsoft did was they said, one of the cool features is let's use the machine learning inside Visual Studio. So let's say they introduced something called IntelliCode. So notice the stars. Hopefully you can see this. Typically, they did a machine learning algorithm on GitHub. All of the code in GitHub, and they said, what's the most common model properties or methods on a class? And let's put those at the top of the list. It's called IntelliCode. So you see the stars here, empty, format, or null. I mean, how many times do you use string, compare, ordinal? So they went through and they said, well, let's use our own, let's use our own dog food and show the data. So it's pretty cool, if you ask me. That'll be available as an extension right now, but hopefully it'll be in the product when they finally release. So if you actually want that, I believe you can use it in 2017 by Get Tools and Features. No, extensions.
Look at your own code. That's what you're doing versus someone else's, because I program it differently than someone else.
So you can train it on your.
Yep. Thank you. So you can actually train your own models at your own company to be machine learning ones that you want at the top of the list. Yep. It's pretty cool. So this comment is he believes that you can do it in your own code base automatically. And I'm not certain of that. I think you actually have to do something right now.
I think you do too. Last time I did it, it said, you want to go through your code? And I said, yes.
So you have to approve it.
The one that automatically does it is the add-on that ReSharper actually does learn for your project.
So another comment was that ReSharper has got something like this too. So awesome. Okay. So little sideline on that, but they're using their own thing. I thought the sentiment was a good way to show things. So one of the comments then was, okay, so now we have automated machine learning. That's why everybody came here, right? So to let you appreciate some of the advancements that are going on, there is, Google has something like this, AWS has something like this, and Microsoft rolled their own also. And I believe all of them are doing something slightly different. It was announced back in September. They highlighted it heavily in our Dev Intersection conference. And they had quite some really, really nice presentations on it. But the why would we automate this? Well, I was looking at a YouTube video last night on this, and data scientists can be biased. They want to find the data that they want to find. They want to use their algorithm that they're familiar with. Hence, they could pick a poor model, and that takes a lot of time. There's a lot of money lost. One of the lures of data science that I always had was, well, I could spend half my time in data manipulation, but the other half of the time I'm actually getting paid for what I really know. And we all feel it would probably be better if they could spend more time on what they know as opposed to just simple bit twiddling. So let's go into a demo on how to actually do automated machine learning. So how do you actually set it up? All right, so I'm going to escape out of that. So something I had to learn was, I thought, okay, let's search for how to do automated machine learning. There's a few things out there. I could go to Azure. I thought it would be great. And what I found was there's a place out there called Azure Notebooks. Okay. And I thought, okay, well, if I go into automated machine learning through this is how the conference presented it. I thought everything's going to be great. Well, I spent 2 weeks trying to figure out how to wire it up to Azure. It was quite an interesting issue. So what I found was you actually need to go to Azure first. And we're going to create a new resource. And we're going to go machine learning. We're going to create a workspace. There is a machine learning service workspace. All right, so let's go ahead and create one. And we'll give it a name. We want to create a new resource group. I'll explain why here in a second. Demo 1 resource group. W. Okay, and we'll go ahead and create it. And I timed this. The last 3 times I did it, took a minute to run. So I'm hoping Azure's not slow on me today. So while we're doing that, I'm going to double check. Okay, so one of the things that it's doing behind the scenes that's kind of cool is it's actually creating several resources. One of them is a VM. And Troy, you might be able to help me here with how to change it and make it faster, but I haven't figured out how to change the VM much, but it's creating it for me. You can go to different cost cycles to make things faster. Everyone's learning. So
Even the machine.
it is, and the machine. Thank you. So we'll let it think here for just about a minute longer. Well, for less than a minute. All right, now it's done. Good. I'm saved. This is always the fun about doing a live presentation. So we went to the demo, and so what happens here is we could look at our machine learning workspace here for a second. We can run experiments, build images, create a pipeline. Notice this, go to Azure Notebooks. Okay, well that was interesting. I'm gonna go back here, oops, go to the resources. And I'm gonna go get started in Azure Notebooks. All right, so yes, we wanna clone the project for the 4th time. And turns out Azure Notebooks has a free environment, so you can play all you want in free compute. If you want to be specific in Azure and start paying for things, you can. So the free compute is an easy way for you to play around without any worry of cost. You can also run local files against this, so you can use Azure Notebooks online. But surprisingly, and I was happy to see this, Azure Notebooks, as they tried to rebrand it, is Jupyter Notebooks. A lot of the Google and AWS, they all know about Jupyter Notebooks. And you can run it locally. So you can run all of this and hit Azure and come back in the automated machine world. So if you wanted to run your own local service, which I did set up, it works. But I like the integration online and the fact that I don't have to set up the computer. So this is what we got after the thing. We can run an experiment, and we'll kind of go into this. We can, if you notice this Jupyter extension here, one of them is tutorials, and tutorials runs across regression, automated machine learning. So right out of the box, you get an automated machine learning Jupyter notebook. So let's go into it. The coolest thing, though, I have to back up one thing, is right here. Notice this upload from URL. I could go to a GitHub repository and pull in a notebook. And this notebook right now is tied to my Azure account, the way we did things. That was a critical part that I have to share. All right, so back to this notebook. So Jupyter Notebooks, for those of you who don't know what it works or how it works, is simply a script that allows you to mingle code and descriptions. If I wanted to insert a cell below, and then I wanted to change it from markup, code, convert, heading, I could change it to code or markup, and it mingles in so that anyone who wants to know what's going on can basically walk through it and learn. So there's a couple ways. I can either hit run, and it just runs markup, or I can run code. Notice the star. So the star means it's running. Okay, and this one here takes a second because I'm importing the Azure Machine Learning data prep. Or, notice the one it just finished. Or I can hit Control Enter and it runs a line. Or I can hit Shift Enter and it runs a line and moves to the next. So if I hit Shift Enter, it's running the next one. So this model, this regression data prep, is going to be needed for our automated machine learning. This whole model is going to scrub our data, do a few things, manipulations. We'll walk through this it takes about 5 minutes to walk through. And it's basically going to create a training, and it's going to create a training model for us. Data for the training set, as we've been talking about. So we can jump through this. I'm just going to give it a minute here, give you guys a chance. So when they originally presented this, oh, looks like we have food. This is good. This is very good. So we'll break here in a second. But what I'd like to get right now is basically, so you can see here, what it did was it grabbed our paths, grabbed our data, and it's showing, in this model, we're going to look at New York City cab fares. And we're going to automate it and see which one of those machine learning models will match this well. Okay, so Jen, let's go ahead and break for a second.
Let's do that.
And grab some food, guys, please. We'll probably reconvene in 5 to 10, so please.
Is this before you create your pipeline or after you create your pipeline? I'm sorry, I came in.
No, you're fine. So let's go through this.
The biggest problem is you have to make sure that your pipeline is actually created that compares apple to apple. Because
Sorry.
the biggest problem with data prep is that the problem is not actually the regression analysis. The problem is to make sure that you create a pipeline that compares, make sure that the data is apple to apple. Because along the line, you want to have apple to orange in your pipeline. You are going to have problems, errors.
So you're referring to, sorry, you're asking about the pipeline in before or after?
These are already scrubbed, right? You've already scrubbed.
No, we're going to, so data is not already scrubbed. We're going to scrub it. So we're going to walk through in this Jupyter Notebook how to scrub the data, but I'm not going to go into too depth because it's going to take a lot of time to kind of clear that with this audience. So I want to get to the automated machine learning part and highlight that as opposed to just scrubbing the data and focusing on the data.
Because what I'm saying that the quality of results that you get
depends. Yeah, the quality of the results does depend on how you scrub the data ahead of time. Yes, correct. So good. Yeah, let's grab some food, guys. Thank you.
Okay, so. Sorry that they're late and they're a little cold.
Yeah, no, so let me catch you up to this. First,
Green cheese is the normal podcast, or is it just chicken?
how machine learning is.
James Quinn.
It's kind of.
Bean and cheese, regular taco, chicken taco.
Yes. We can show the microphone.
Well, that's not true.
I know he's gonna be like an old linebacker. Well, he's 98% out of everything. And he's incredibly strong, my gosh. 18 months.
There's no.
Yeah, no, I agree.
How do the girls together?
Oh, they're great. Yeah, they're doing pretty well. We're pretty lucky.
Being 17.
Really?
Yeah, it's such fun.
Like a reality check.
Yeah. And you know what? Like we're really sad. I mean, you know, one never having.
Yeah.
Which was
Years apart for us.
It's just really quiet for the rest of the staff.
Well, once I get some food down, we'll start back again. I'm hungry.
Sorry, everybody.
You can't walk out.
Everyone, if you want some more.
Forgot how good that was.
We wonder if it's the largest piece of change in the world.
Really?
It's the largest in the country. We're seeing.
I would have thought that.
People I mean, even if you're not a member, you just walk past the building, that walk, checking your card or anything. Oh, did they?
All right, I got something down my belly, so let's go ahead and keep going. You guys are welcome to eat. Please do. All right, so it was pointed out that really part of the data science world, part of the machine learning world, is to make sure that you scrub your data in a way that you can actually figure out the right algorithm to use. That's very important. So for the moment, for the purpose of this discussion, I'll have another brown bag I think is appropriate to get in how to do that. But for now, I'm going to focus on the machine learning side, the automated side. So let's walk through this author's approach to how he scrubs the data for a brief minute. So he's downloaded the two data sets, and they're slightly different. They're auto-reading the files. So this is kind of a view of the first 5. So we're going to clean the data. So in other words, you really don't want anomalies. Again, I'm going to hit Shift-Enter. And this is cleaning the data. In other words, which columns are useful. Some reassignments, some transformation steps, just renaming columns. All right, so the benefit now is we've cleaned the data. We're gonna, something you'll run into too, I'm sure everybody has, you've got types where some are strings, some are int, so you need them to be the opposite. So we're gonna go through that. I wanna wait till that completes. All in all, I've been very happy with Jupyter Books. There are R is out there, some Python scripts, things like that. And but I've been generally happy with this. So, okay. So again, we're doing transformations. Okay. Now we're going to split and rename some columns. Again, cleaning the data, scrubbing it. And as I said, this doesn't take a lot of time. I was kind of upset at the presentation we had at the Dev Intersection. They went through and just showed it and scrolled. It didn't go through it. Just couldn't have a chance to see what they're really doing. All right, so if you notice here, we have quartiles. We've done some standard deviations, some statistics. We're going to transform that data now. Rename some columns. Look at the first 5. So honestly, this here, if you can appreciate, this is what your data scientist is going to do. And it's important that they do it right. At the same time, they're going to redo it over and over and over until they get it right. And this is part of the magic. So when I was doing go ahead and run this. When I was doing the Titanic example, when we were presenting it earlier, it's amazing. You can go online and you can see different people doing tutorials, and they're all doing different things, but generally the same results occur. It's all about trying to match the model. You can overmatch it, by the way, too. You have to be careful about that. All right, we're just about done. Okay. All right, so what we've done here is we're now saving out the data prep. Okay. Now, I can jump here to the next training regression and see what's going on. If you notice also here, I can go to my projects, and it's simply the same file that I found here. Okay, so now's the cool automated part. We want to go that one. All right, so you can see here we're going to run the model. We're going to import the packages. That takes a minute. But I want to highlight one that's really kind of cool. You see this pandas. For those of you who do any machine learning, pandas is a really good library to show data. So one of the things that's pretty cool while this is running too is you can come here to help, and you can see Python reference and various other references, including a panda reference, for example. So you can know the commands, and it's all within the book. Okay, so this here is the gonna gotcha. This here, this step is the thing that eluded me for 2 weeks. How the heck do I get it tied up with machine learning? Well, it turns out this really here, as long as my book is related somehow to my Azure account, in this case I went from Azure into this account, then I can open up this login and log into my Azure account in Jupyter Notebooks. And I'm connected. And voila. So now I want to explore the data. So bring in the data that we just produced in the other file. And of course it's, I honestly don't know how large it is. I hadn't thought about that, but it takes a second here. And then once it gets in, come on. I did time this so everyone's not utterly bored. Oh, I was mistaken. So we have our data file, and then I'm going to split it to a training and a test set. So come on. Really close to the automated. Really close. Come on. There we go. All right. So again, this is a sample of our file from the other one. Okay. So now we want to only look at certain columns. And we want to split our data into a training set and a test set. As soon as that finishes, we'll be on the automated side. So I did look into how to automate machine learning. I can run it local with this book, run on my own machine, get it running with my own resources, which might run a little faster because this is a shared set of resources. And I can connect to Azure, but I didn't focus on that. I've really enjoyed the online approach. So we have data. All right, so let's go ahead and start the automated machine learning, and I will come back to explain what's happening. So we apply our settings, iteration timeout, number of iterations, the type of the metric, what are we looking for? And we're going to start we do our import for the config, and then we're going to start it. Okay, so we just started the machine. You can see it's going to run. I'll show you some cool features here. I just want to see the first one. Come on. Okay, and we're starting to run, and we're running in our Azure environment. There we go. Okay, so our first algorithm is being tried, and let's see which one it chooses. No, it takes 30. The first one usually takes about 30 seconds. So while that's going on, let's kind of look at this. Notice this. So automatically training the model. Well, we have to define it, the settings, and then run it. Here's a list of settings. So let me show you a little bit about what you have at your disposal. If you remember back to our previous discussion, you have classification, regression, and forecasting. These are different types of models. And these are the ones available to us now. They can run all of these. And the intent is to figure out which algorithm would be best. Microsoft does their own internal things to decide which one algorithm, which one to decide. But we're going to see the raw numbers. So it's pretty cool. So if I come back over here to where it's running, it's going to pick the 5-minute one. So I already have this up for everybody so that we don't have to wait. Oh, there's the first one. It shows the extreme random trees, max abscaler. I'm just curious which one. Decision tree.
Middle column, at the bottom.
Oh, there it is. Extreme. Yeah. Okay. So it chose to try that one. And, it took 1 minute and 13 seconds. This is currently the best. And it'll go through this. And I told it to run 30 of them. Okay. And it may pick the same model and try a different angle or a different variation. You have to understand what's going on behind the scenes. There is a massive amount of variables in play. Instead of hand picking 1 or 2 or 3 different things and running the model, they're picking thousands of combinations of various things. It's really where I, as a lowly developer, can utilize the cloud and its massive resources. That's the cool part.
Choosing variables like this or what?
Internally?
Choosing, I fed that. He said either it's drawing the regression formula anyway.
Yes.
Based on the variable that you give. Is it going outside of that?
It is. It's trying to tweak some of them, yes. That's as far as I read the articles. So the question was, is it choosing the variables beyond what I told it to? And my belief is yes. So it's.
So where does it see data? Where does it see data set?
So which data sets? It's the data.
Which data set is it going to use for those choices outside?
No, it's not going to use the data set. It's going to use some variables. Whether you should, so for example, if you're using a decision tree, whether you break, how far deep do you go? I'm limited in what I know of some of these models. So the question essentially is, how is it determining what's going on? What I noticed when I'm running the models is it will use the same decision and reapply it, and you'll get different results.
I would think that it does that's what they call auto collinearity, try to draw auto collinearity to your various data, or it's doing an auto stochastic stuff like that, and this can take a decision and then draw it into where I didn't know that. Go ahead.
Yeah, let me go deeper with that by explaining some of the results. You'll understand after I show you some of the results. So it's going to keep going, and it'll go 30 iterations. Every time I ran this, it took more than an hour to complete. So what I did for everyone's benefit is, and for my own, I ran it already, and I'm going to show you some of the results. So it's the same code, same everything, exploring the data, training it, and here's 30 iterations to give you kind of an idea of what it did. You can see here, it decided to try this one multiple times to see if it could get a better result. Yep, same regression model. How it does it, I have, I'm sorry, gentlemen. You should have told me earlier. Okay, so you can see here, it tried several things. You can see here it tried the same algorithm, but it has different results because it's tweaking a little things behind the scenes. And I'm still trying to understand what it's actually doing. But here's some of the exploratory results. This kind of reviews it. One way to look at it is a Jupyter widget. And I can open this up in Azure, for example. Oh, I'm sorry. I closed my resource so I wouldn't have the VM running. So my apology. I don't want the VM charged. So you can look at it in Python and what it's doing. So hopefully this means something to you.
So that graph that it showed, is that the quality of the results over different regions? What was that showing?
To be honest, I don't know. So I know that you got mean, you get mediums, you got normalized means. For example, yeah, it is impressive, right? Correlation values. These are over the 30 of them. They're ways to see how it decided to stuff. For example, here's some code to retrieve the best model. Which one was the best model? What I found is you really have to run more than 30 iterations. In this case, you can see here, this ran these, but if I go back to my other model, it hasn't run that particular decision at all yet. It's the same data being fed into it. So option 1, option 2, what's the best one? And then what's cool is I can register the model, so I can go look at it. And then I can test it. So again, my intent in this discussion was, how do you get started? What are you looking at? What are some of the terms in the industry? What are you worried about? I'm kind of summarizing, basically saying, this is great. This is awesome that I can leverage such an available resource with almost little to no cost. I'm going to double check to make sure I didn't lose anything. For example, it's the Azure notebooks are free. Azure's not, but you can keep it down. There's some good Pluralsight courses on Jupyter notebooks. There's some tutorials out there. I showed you one of many out there. Beyond that, any other questions?
So all those things you were running in that notebook are running in the VM that was created when you created it?
Just the Azure part was, yes.
So if you didn't want to speed it up, you just bump up the size of the VM?
Yes. Yep. You can bump up the size of the VM. Any other questions? Much to the credit of your knowledge, I'm data science is still a beginner for me.
In terms of the cost, you mentioned Azure is low cost. Yeah, some ballpark.
Less than
figures.
$1,000 a week.
Is that what it is?
No, you're basically running. You're running a VM, and the VM cost could be, I've seen them as cheap as $40 a month. I've seen a lot more.
Well, one thing that you can do in Azure VMs is you can have them do an automatic turn off. So, which is probably a good idea for something like this. You just say every night at 7 o'clock, if it's running, turn it
Right,
off.
exactly.
So that you're paying for when you're sharing.
Yeah, so the comment was basically just you can turn off VMs automatically. So, awesome. Any other questions?
That was the place we were talking about integration with Python. So what does that mean? That allows you to incorporate Python stuff into it.
So you're talking about Jupyter Books. How is it integrating? Yeah. So for example, here, in Jupyter Books, I can introduce code, some markup, some I don't even know what that is, and a heading. So it's essentially, you know, my heading. I have to run it. Yeah. So, or I can add a cell above, and I can put some Python code in. You know, and run it. So it's pretty versatile. I have seen something when I'm running, it doesn't appear that online I can do F# or anything like that, but when I run it locally, I can do F#. I can definitely do Python in like different flavors of versions. You can see here it's running Python right now. But when I run it locally, I have a lot more versatility. So the coolest thing too is it shares. So I can share it with you. I can share, you know, this is public. You can actually, everything I did today, minus logging into my Azure account, you can see. So, and I'll probably delete the VM, so you won't be able to run it, but either way. Any other questions?
Once you run through this whole process, if you want a better model, you just run it. Right? How do you use this process again to get a better model and feature, or you start from scratch?
No, I would use the same model, same approach and get a better model. You can also rescrub your data again, reanalyze it. The question is what do I do after the fact? You know, how do I revisit this? Ultimately, you're going to end up with a model and an approach and the data for it, and then you can go into, for example, in the ML.NET and run that model and have that model with my data already prepared. Quickly spin up something and use it in your code right away in an application pretty quick. So these are tools, and it's a good way of documenting what you're doing to the benefit of others, so they can see problems, holes. I'm sure you guys have had peer reviews. Any other questions? All right, I think we're good. Please feel free to have more meetings. Have more food. Thank you, gentlemen.